In empirical formula, whenever you are given a question under empirical formula, sometimes they might give you the question in terms of percentage composition by mass. Are you following? Yes, why sometimes they might give you in terms of the reacting masses. Okay, the value given to you will be if in terms of what? Mass. Why in some cases it will be in terms of what? Percentage, just like this question here. Whenever you are given a question in terms of percentage composition, percentage is what? 100. Are you following? What you will do, you add up all the percentage given in the question, you add everything to what? Together. Are you following? And after adding them together, then you subtract it from what? From 100. But if you add everything together and if it's up to 100, are you following? You go ahead and do your normal what? Calculation. But when you add up everything together and if it's not up to 100, okay, what do? You subtract the value that you've added together, you subtract it from what? From 100. So the leftover, you take it to be your what? Oxygen. Are you following? Let's assume maybe we were given like 3.58 the percent, and maybe the other comma we're giving 60.89 what percent. Now what do? You add up these two word compound S and word compound what? Y. So it should be what? S plus what? S plus Y. Are you following? So you add all these two compound together, which is 3.58 plus 60.89. So if you add all these two things together, what do you have? What do you have?
64.09.
What do you have? 64 point what?
09.
So we have 64 point what? For what? 47%. Is it up to 100? Is it up to 100? So that means this thing is not yet what? Complete. What do? You do which is 100 minus 64.47. Are you getting it? So 100 minus 64.47. What do you have?
35.35.
By 35 point what? 35 what percent?
No,
52.
So 52. 35 point what? 53%. So what you do? You now take this one to be your what? Oxygen. But supposing when we added all these two values, please pay attention, and it was up to 100. So no need of you subtracting anymore. Are you getting me?
Yes,
so you just go ahead and do your normal word calculation. All right. Now this time around, let's work on this question. And in terms of molecular formula is multiple of your what? Empirical what? Formula. Are you following?
Yes,
Molecular formula is what? Your multiple of your what? Empirical what? Formula. Is that clear?
yes.
Now the thing that for you to get the value for n, so you make use of the which is your what? Empirical formula, EMF, then n, then equals to molecular mass. Okay, equals to relative molecular mass. Now this the value you use to get your what? Your n. Are you following? All right, so let's proceed. Coming back to this play, please pay attention. We are told that an organic compound contain what? Carbon, hydrogen, and what? Carbon, hydrogen, and what? Now the compound contain carbon, it contain hydrogen, and it contain what? Oxygen. And we are told that on analysis it gave 41.4% carbon. We are giving the percent of carbon to be what? 41.4%. Is it not? All right. And 3.1% hydrogen. We are giving percentage of hydrogen to be what? 3.1%. Then we are told that and heat vapor density is found to be 58. Here we are giving vapor what? Density. And what is our vapor density? 58. All right. Sometimes you will not be giving your vapor density. You will be giving molecular mass. Are you getting me? But if you are not giving molecular mass and you are giving your vapor density, to get your molecular mass is twice your vapor density. Are you following? All right. So this time we are asked to calculate the empirical formula and the molecular what formula. Now this is how to go about it. I was giving you in terms of percent. What did I say you do? You add up the two together. That is C plus H, right? That is 41.4 plus 3.1. Add up together 0 to 100. What do we have? We have 44.5%, right? That what do we have to subtract this from 100. You can see now what they give us was just carbon and hydrogen, and the compound contain was carbon, hydrogen, and what? Oxygen. Are you following? So this time I will have it as 100 minus 44.5. So what do we have? 55.5. That is 55.5%. So with this now, we now add that of what? Oxygen. So now that you now have carbon, hydrogen, and oxygen, you can calculate for what empirical word formula. All right. So from here, this is how to go about it. We have elements. The element give you according to how they gave you. They gave carbon, hydrogen, and what? Oxygen, right? Yeah, carbon, hydrogen, oxygen. We have carbon, we have hydrogen, and we are giving oxygen. The after that is the percentage by mass. What was the percentage of carbon? 41.4. Hello, please pay attention. We are still using this formula. N is equal to mass over what? Molar mass. Are you following? Mass over what? Just that this mass is percentage composition by what? Mass. In some cases, please pay attention. Maybe yours, what they will do, they might not give you in terms of percentage. They will just give you in terms of what? Gram, which is mass. Are you getting me? If you are giving in terms of mass, no need of you adding up and subtracting. Are you getting me? The main reason why we added up and subtract because it's percentage, and percentage is what? 100. Is that clear? So when we were giving in terms of mass, maybe each one was in gram, you just go ahead and calculate like that. Are you following? So that then you not write percentage by what? By mass. You can either write just mass or you write reacting what? Masses. Is that clear? So the percentage composition by mass, we are giving carbon to be what? 41.4. And hydrogen to be what? 3.1. Oxygen to be what now? 55.5. Then after that, we'll divide by what? Molar mass. And if you divide your mass by molar mass, what are you going to have? What are you going to have? Mole. So the next thing is our molar mass. What molar mass of carbon? 12. Molar mass of hydrogen. And molar mass of oxygen. And if you divide this, what are you going to have? You have more, right? All right. If you divide it, what do we have? 3.45. Is that all? Yes. Just 3.45? Yes. All right. It's advisable that you always approximate to what 4 decimal word place. Maybe the values are much. Are you getting me? You approximate it to how many? 4 decimal place for it to have an accurate result. So this divided by we see have 3.1. And this divided by this 3.468. That is 8. Is it not? 688. You can see it now. All right. So this time around, what's the empirical formula? The simplest whole number. Are you getting me? The smallest. You are going to divide by the smallest number. Are you getting me? The smallest number here is what? 3.1, right? You divide through by 3.1. So here will be divided by 3.1, divided by 3.1, and divided by 3.1. Please, are you getting it? Yes. All right. So from there, after that, we are going to have what's called mole ratio. If you divide, what do you have? 1.11. It should be in ratio. It's setting as 1. Are you following? The approximate. Then divide this. We still have 1, right? The ratio. This divide this, we still have 1, right? Now the next is our EMF. Now please pay attention, let me explain this. In some cases when you divide, are you following? You might have like maybe the approximation for empirical formula start from what? Not from 5, it start from 6, 7, 8, and so on and so forth to 9. Are you following? Why the round down number, okay, is from 0 to 4. Whenever you are having 0.5, hello, whenever you are having 0.5, you don't approximate. Let us know we're having like 1.5. Are you following? You don't approximate to what? To 2. But if it's 0.6, you approximate to what? To 2. If it's 0.7, you approximate to what? To 2. If it's 0.8, you approximate. If it's 0.9, you approximate. But if it's 0.5, you don't approximate. What do? You multiply everything by 2. You multiply by what? At the end, when multiply by 2, then here become 1 times 2. Here you have 2. This time you have 2. 2 times 1.5, you have what? 3. Are you following? When I mean 0.5, it can be 0.5, it can be 1.5, it can be 2.5. Are you following? As long as what? 0.5. Is that clear? All right. So this time around, our EMF, which is the empirical formula, is written as C1, then H1, and what? O1, which is what? CHO. Is that clear? Yes. Now this is my what? EMF. Now the next thing that we have to look for molecular what? Formula. For we to look for molecular formula is M bracket EMF. Are you following? Yeah. And our EMF there is what? CHO. That is SCHO. Please pay attention. But the issue there is, do I have my N? No. Do I have my N? No. I don't have N. I have to look for what? N. Are you following? So what do you do? So for you to look for N, okay, you make use of that is EMF N, EMF or EMF N. Then equals to molar mass or molecular mass. But the issue there is, I don't have my what? Molar mass. I was not giving molar mass in the question. Yes. Are you getting me? Yes. Instead, I was giving vapor density. So you can get your molar mass from your vapor density. Are you following? Now to get molar mass from vapor density, molar mass is twice of vapor density. So molar mass is equal to 2 times vapor density. Are you following? So we are giving our vapor density in the question to be what? 58. It should be 2 times what? 58. So we have 2 times 58. 2 times 58 give you what? 116. So this time around, so we can move back to this place, which is EMF. What's our EMF? CHO. Then our CHO. The N equals to what? 116. Are you following? Now the issue there is, I need to look for the molar mass of this compound. You already know how to look for molar mass, right? Yes, sir. You already know how to look for molar mass, right? Yes, so from here, carbon is how many? 12. That's 12 times 1. Then plus hydrogen. 1 times 1. Then oxygen. 60 times what? 1. Then all bracket what? N equals to 116. So 12 times 1 give us what? 12 plus 1 plus 16. Then we have 1 N equals to what? 116. So 12 plus 1, 13. 13 plus 16. 39. That's 29 times N is 29 N equals to 116. Are you following? To get N divided side by what? 29. So N will be equal to 116 divided by 29. What do we have? 4. We have it to be what? 4. Now you can see we succeeded in getting N, right? Yes. Normally the formula for molecular mass is multiple of what? Empirical formula. Is it not? Yes. So what you need to do, you substitute this 4 into this place. Are you following? Yes. So from there now, it becomes what's our N? 4. 4 bracket what? CHO. You know what to do here? Yes. You use 4 to open up the word, the bracket. 4 times C. C4, H4, and O4. So these are molecular formula. Why this is our what? Empirical formula. So you can copy that. No. That one is from my idea, but this one don't have it. Its composition recorded as what? We are giving 2.67 grams of carbon, 2.67 gram, and 0.45 gram of hydrogen. We're giving hydrogen to be 0.45 gram, and 3.55 gram of oxygen. We are asked to calculate the what? Empirical formula and what? Molecular formula. Yeah, we are giving relative molecular mass, right? So our relative molecular mass was given to be what? 60 mol, right? Atomic mass unit. All right. Now you can see now this one it was given in terms of what? Gram. Is it not? Yeah, do I need to add up anything? You just go ahead and what? Calculate. So from here we have elements. And the elements are carbon, hydrogen and what? Oxygen. Then after that we have what? Reacting masses. So what is the mass of carbon? 67. And mass of hydrogen? And mass of oxygen? 3.55. Then after that we have what called molar what? Molar mass. What molar mass of carbon? Molar mass of hydrogen and molar mass of oxygen. When you divide, you are going to have what's called what? Moles. So 2.67 divided by 12. Approximate to 4 decimal place. What do we have? 223 what? So we have 2.67 divided by 12. It's already 4 now. 222 what? 5. So if you divide it, we still have 0.4 what? 5. And when you divide the 3.55 divided by 16, 0.2219 approximately, right? So this time I divide by the word smallest. So which is the smallest here? 0. What? 0.45. 0.000242. 4 is greater than 2. Then this one, the next one is 2, 2. They are equal. The next one is 2 and 1. So which one is less? So this is the lowest, right? So the lowest is 0.2219. Are you following? 0.2219. 0.2219. When you divide it, you are going to have what's called mole ratio. So if you divide this, what do you have? It's taken as 1, right? Then ratio. If you divide it, what do you have? 2. So we have 2. Ratio 1, right? So we give us what? Our EMF to be C1 H2O1, right? We give us what? CH2O. All right. Now that you've gotten this, now you are asked to look for what? Molecular formula, right? And our molecular formula is multiple of your empirical formula, right? Like N bracket CH2O. But the issue there, we don't have our what? N. We have to look for what? N. To get our N is NCH2O. Then equals to what? Molar mass, right? Or molecular mass. So from here we look for relative molecular mass of this, right? So we have N. Carbon is what? 12. Then plus hydrogen is 1 times 2. Plus oxygen is what? 16. Are you following? Then the molar mass given was how many? 60. All right. So 60. So we have N bracket 12 plus 2 plus what? 16 equals to 60. 12 plus 2 plus 16. That is 30 what? N equals to what? 60. What do you do? The Bible said by what? 30. So N will be equal to 60 over what? 30. What will be N? N will be what? 2. So our molecular formula now, don't forget, is what? NCH2O, right? So you already know what's your N now, right? N is how many? We call 2 brackets CH2O. So 2 times this C2H4O2. So that's your final answer. Of iron contain 69.9% by mass of iron, right? So we're giving the percent of iron to be what? 69.9%. All right. We are asked to find the empirical formula of the what? Of the compound. Okay. Now, hello. That's the only value given to us. And please, no noise. How do we go about that? Now, you subtract this from 100 to get out of oxygen, right? And oxygen will be equals to 100 minus what? 69.9. Are you following? So what are you going to have? That is 30 point what? 1%. So we've gotten the percent of what? Iron and percent of what? Oxygen. So with that, can I go ahead and what? Calculate. Now we have elements. The elements are what? Iron and what? Oxygen. Are you following? Then after that, we have a percent by what? By mass. What the percentage of iron? 0.9. And what percentage of oxygen? 30 point what? 1. After that, you divide by what? Molar mass. The molar mass of iron is what? That is 56. That is 55.5 here, approximately what? 56. Then the molar mass of oxygen is how many? 16. All right. Now, you will be giving those molar mass in your exam. Are you following? All right. So this time, when you divide, we are going to have what's called what? Mole, right? When you divide it, what do you have? 1.8 what? 82. And if you divide this, what do you have? 1.1 what? 2. So after that, we divide by the what? By the smallest. So between these two, which is smallest? 1.2. That is become 1.2482 divided by 1.2482. After that, we are going to have what's called mole ratio. Are you following? So if you divide these two, what do you have? Is it 1? 1 point what? Just 1. All right. So if you divide, what do we have? 1.5 what? It's okay. The ratio 1.5. I told you that whenever you are having 1.5, what do you do? What do you do? So this one become times what? Times 2. Are you following? So at the end of it, you have it as what? 2 times 1 is what? 2 ratio. 2 times 1.5 is what? 3. It become, to get our EMF now, it become what? Fe2O3. Chicken now. So that's it. So you can copy that.